Hello, welcome to my pre-calculus project for Semester B. My name is Cara and I am going to be taking you through my chosen topic of elliptical planetary orbits, where I am going to be calculating how many miles per hour in Earth hours Earth, Mercury, and Saturn are orbiting around the Sun. However, first I'm going to be analyzing and creating data for each of the planets using a data table, graph, and equation to solve for the necessary parts in my overall question. This first problem, I'm going to figure out the equation of Earth's orbit from a data table that gives the eccentricity and distance to the Sun on the semi-major axis. So here is the data table, but also remember that Earth's orbit is not exactly circular, thus its orbit is an ellipse with a semi-major and semi-minor axis. It is also important to note that a unit of AU, as seen in the table, represents Earth's distance from the Sun. So when you see units of AU further on in the presentation, remember to think in regards of Earth's distance.
Okay, so this is the data from the table that was previously shown. So we need to find the equation for Earth's elliptical orbit. So I'm going to write the equation of an ellipse, which is this. So here is the equation. Now, we have the distance from the Sun on the semi-major axis, which is 92,955,807 miles. So this serves as our A value. Now, we need to find the B value. So let's write. So our B value is going to be found through this equation, which is, and we already have the eccentricity. So the eccentricity is 0.0167 over our A value, which is 92,955,807 miles. So really quickly, if we multiply 0.0167 by 92,955,807 miles, we're going to get our C value, which is 1552361.977. So we have our C value, but we need our B value. So it's going to be found through this equation, C squared equals A squared minus B squared. So our C value, we're going to plug in 1552361.977. We're going to square that, and that's going to equal our A value squared, 92955,807, minus our B value squared. So real quick, we're going to square our A value, and then we're going to square B value, or our C value. And then from there, we're going to, B can go over to the sides, we're going to subtract our C value from our A value to get this, and then we're going to put our B squared value under the square root, and it's going to come out to equal 92942843.87. So our final equation for Earth's orbit is going to be x squared over our A value squared, so 92,955 squared, 807 squared plus y squared over our found B value squared, which is 92,994,2843.87 squared, and that's all going to equal 1. Now it's important to note that we use the semi-major axis, so our b value was going to be smaller because it is the semi-minor axis.
So this is the final equation for Earth's elliptical orbit. Now, for our second problem, I'm going to, based off this graph, determine the elliptical equation for our next planet, Mercury.
So based on the previous graph, we're going to determine the equation of the elliptical orbit of Mercury. So here are the 4 points that were on the previous graph shown before. As you can see, they're in an elliptical pattern, so I'm going to briefly draw what the points look like. X and Y axis. So you have negative 3.598 times 10 to the 7th is 0, so that's going to be around, it's going to be around here, and this is going to be around here. And then, so this is the semi-major axis. This is the longest part. And then the center here is going to be the sun. So now it's not in a perfect ellipses, but this is just how we're representing it here. So the bottom is negative 2.9 times 10 to the 7th, so it's going to be right over here because it's about negative 2.858 times 10 to the 7th, and then up here is 2.9 times 10 to the 7th. It's going to be right about there. So this is going to what our ellipses is going to look like. A little bit better drawn than that, but so that's Mercury's orbit around the sun. Now we need to determine the equation. So what we have here is the points. So the equation of an ellipses is x squared over a squared plus y squared over b squared, all going to equal 1. So we have the a and b's. This is the semi-minor axis, and this is the semi-major. So the semi-minor axis is going to be your b value, and the semi-major is going to be your a value. So your a value is 3.598 times 10 to the 7th, and your b is going to be 2.858 times 10 to the 7th. Just to make it a little more accurate here, it's going to be x squared over your a value, which I'm just going to write it out in millions. It's going to be 35,983,115 miles there. So you're going to square that plus y squared over 28,583,820 miles. Don't forget to square that there, and that's all going to equal to 1. So this is your final equation for Mercury's total orbit around the sun.
So just to reiterate, this is Mercury's total equation around its orbit around the sun. Here, this is already squared, the a and the b value. And again, this equation was found only from using a graph.